Look up. What do you see? A few hundred feet of open air, maybe some tired skyscrapers, and beneath you, a sprawling two-dimensional grid of asphalt and congestion. This is the legacy city, a structure that fundamentally cannot handle the billions of people pouring into our urban centers. It's flat, slow, and choked. By the year 2300, 90% of humanity lives in what we now call a megacity. Now close your eyes and imagine the city of 2300, a kilometer-high vertical habitat where millions live, work, and commute within a single massive arcology. The ultimate, inescapable question for this hyperdense megacity isn't how to build it, but how to move inside it. How do you solve gridlock when the entire city is stacked on top of itself and its population rivals a small country? The answer lies in tearing up the rulebook. In the 3D city, movement isn't a problem. It's a perfectly calibrated, automated utility. Welcome to the future of urban mobility. The end of the street. For centuries, urban design was dictated by the car. Streets were built for individual vehicles, leading to the sprawling, inefficient urban landscape we know today. This was the era of the two-dimensional city. In 2300, the street as we know it is functionally dead. No more traffic lights, no more human drivers, and critically, no more bottlenecks at ground level. The city reclaims its surface area, transforming asphalt into vertical farms, public parks, and communal spaces. Movement is handled by three interconnected layers: the subsurface, providing high-speed regional transport; the ground plane, strictly reserved for micro-mobility and pedestrians; and the vertical and aerial plane, managing the vast internal and external commutes. At the core of this transformation is the realization that personalized, single-user vehicles, the gas or electric car, must become a relic, replaced by hyper-efficient, shared and autonomous systems managed by a singular citywide traffic AI. This shift was the only way density could succeed. The legacy of the car remains, not on the surface, but in historical archives. Today, the mere idea of millions of individually controlled, two-ton boxes moving randomly through a city center is viewed with the same historical detachment as the horse and buggy. Hyperloops, the subsurface spine. Imagine the frustration of commuting across a major metropolitan area today. 2 hours wasted every single day. This was the primary challenge the architects of 2300 had to solve before building up. Their solution, the urban Hyperloop network. Buried far beneath the city's foundations, a web of vacuum-sealed tubes connects every major district and surrounding satellite city, the regional commuter spine. Passengers enter compact automated pods that accelerate using magnetic levitation, maglev technology. With the vacuum eliminating virtually all air resistance, speeds exceed 1,200 kilometers per hour. A 300-mile regional trip becomes a 15-minute journey. The engineering challenge was astronomical, stabilizing the vacuum tubes under the massive kinetic and vertical loads of the arcologies. But the payoff was the complete elimination of surface-level intercity commuter traffic and associated emissions. The Hyperloop isn't just transport, it's a tectonic shift in urban geography. It effectively makes all satellite cities suburbs, allowing people to live hundreds of miles away while working in the city core without losing a single hour to transit time. This subsurface spine also handles massive logistical needs. Separate, heavy-duty Hyperloop tubes manage high-volume, automated cargo deliveries, diverting freight traffic entirely away from sensitive urban zones and ensuring the city's vast population is fed and supplied. Vertical transport, the internal lungs. If the Hyperloop is the city's spine, the vertical transport system is its lungs, constantly pumping life and people through the kilometer-high structure, defying gravity millions of times per hour. Traditional elevators are functionally obsolete in super-tall buildings. They waste space on counterweights, cables, and deep shafts, and they're prone to frustrating congestion, especially during rush hours. The core solution is the multi-directional maglev lift, or the cubic system. These lifts use linear motor technology, allowing them to travel not just up and down, but also horizontally between building cores and across mid-level sky bridges. The cable is gone, replaced by smart magnetic rails. Imagine boarding a lift on the 500th floor of the residential arcology, having it seamlessly travel across a structural sky bridge section, and then ascend the adjacent commercial tower to the 700th floor, all without changing cars or stopping. The cable is gone, replaced by smart magnetic rails. Each vertical core is managed by a localized predictive vertical AI, which constantly monitors and predicts internal traffic flow, grouping passengers by destination using real-time demand modeling. A resident never waits more than 10 seconds for a lift. And furthermore, these lifts operate on a tiered system. Separate, high-capacity, non-stop express tracks handle internal freight, waste management, and emergency personnel, ensuring the human-occupied transit remains unburdened and always available. Drone taxis, reclaiming the sky highway. On the outside of the megastructure, the sky is no longer a silent void. It is the new highway, a breathtaking yet hyper-regulated third dimension of personalized travel. Automated drone taxis, or air cabs, form the primary method of personalized travel between different megatowers and the city's periphery. These are large, electric, multi-rotor vehicles, silent and entirely emission-free. They operate from designated acoustically isolated and wind-shielded skyports built into the upper and mid-levels of every skyscraper, allowing seamless transition from the vertical lift system to aerial travel. But what about safety? With thousands of autonomous vehicles moving simultaneously, the sheer volume of sensory data and kinetic planning is too much for human air traffic control. This is where the city AI takes over the airspace. A single, hyper-aware central algorithm manages every centimeter of the dense aerial volume. It calculates flight paths, predicts micro-weather phenomena, and instantly reroutes vehicles to prevent conflicts before they can materialize. This AI effectively creates invisible dynamic lanes in the air, optimizing every flight for maximum efficiency and energy consumption, turning what would be chaos into a beautifully orchestrated silent dance. This aerial layer enables the ultimate freedom of movement, the shortest distance between 2 points, a straight line. The last mile and seamless transit. Even with Hyperloops and air cabs, you still need to get from the transit hub to your apartment, office, or local market floor. This is the enduring last mile problem, and it's where surface technology reigns. The ground plane and internal residential corridors are dedicated to pedestrians and quiet, autonomous micro-mobility pods. These are small, electric, self-driving platforms summoned via neural link or wrist-worn device. They move slowly, prioritizing safety and immediate pedestrian interaction, and are entirely guided by the citywide AI to their optimal path. They are often personalized, recognizing their user by biometric signature. Crucially, all public transit stops, from the Hyperloop terminal to the Skyport elevator, are designed as seamless, level entry transitions. No staircases, no long halls, just smooth, automated movement from one system to the next. The entire city is designed for uninterrupted flow. For the first time in history, an urban environment puts the flow of people, not the flow of traffic, at its highest design priority, making the simple act of walking or riding a dedicated pleasure unmarred by gridlock or personal vehicle ownership. The AI master of movement. The sheer complexity of these three interdependent mobility systems, subterranean,
Welcome
vertical,
to the
and
future
aerial,
of urban
requires
design,
a central
where every
intelligence that
journey
far
is
surpasses
seamless
human
and serene.
capability. The city AI, the
Look at the
same
detail
consciousness
here.
that runs
It's
the
incredible
city's
how they shape the
utilities,
metal like
acts
that.
as the
Oh, it's
master of
absolutely
movement.
stunning. I wonder what
It
the artist
processes
was
billions
thinking.
of data points per second, from localized energy consumption to individual travel patterns to anticipate demand. If a major event, a sudden concert let out, or a localized fire occurs, the AI doesn't react to congestion, it prevents it. It instantaneously adjusts the speed of Hyperloops, the allocation of maglev lifts, and the flight paths of drone taxis to evacuate or manage the new influx of travelers. This level of control results in a system that is not only efficient, but nearly perfectly energy optimized. Vehicles are always grouped, speeds are precisely managed to minimize friction, and peak energy demands are smoothed out across the entire arcology. The ethics